Once again, I'm grateful for being given this opportunity to make this presentation, recent advances in chemical development of latent fingerprints from this platform. This actually gives me a chance to trace my research from surface-specific fingerprint formulations to broad spectrum ones, which have the potential to detect fingerprints on virtually all types of crime evidence, irrespective of their state and their nature. Just a minute. So fingerprints, basically, this is very preliminary. They are, the crisscross lines which we find on the fingertips. Nature has provided them to us so that we may have a firm grip of the object we intend to hold. And all along, these ridges are studded with small holes, which are called sweat pores. So when our finger touches any surface, it leaves behind a deposition of sweat exactly in the same pattern as is the design on our fingertips. But we can't see that pattern because sweat is colorless. And what we basically do is we try to fix any one component or more than one component of sweat and make it colored by some physical or some chemical means so that the fingerprints, they become visible and we say that they have been developed or they have been detected. Sweat basically contains 99% water, 0.5% inorganic ions, 0.5% organic molecules. And those organic molecules are further subdivided into those which are water miscible and those which are not. And what we'll see later on is that water immiscible components have got a better potential to serve as targets for detecting latent fingerprints. The powder technique is the most trivial one, the most simple one also. It fixes the water and the oily components of sweat. Oily component means the low boiling point organic components present in the sweat. A powder consists of two broad components. One is called adhesive and the other is colorant. And it works on the phenomena of double adsorption. The adhesive gets adsorbed on moisture and oily components of sweat, and the colorant gets adsorbed on the adhesive. Now, this technique, as I said, is very simple, but it has got very, more than one limitations. That when you are selecting the powder, you have to see the nature of the item, the color of the item, the texture of the item. And, our police personnel, they are not well versed with these limitations. And moreover, in a country, tropical country like India, where the temperature is quite high around the year, the water content tends to evaporate in a short while. So that if old fingerprints are there, powder technique doesn't work. Then another version of powders are those which are based on nanoparticles. Nanoparticles are very small particles and they have got the ability to seek out oil or even in the moisture, even if a very small amount is left. And that's why, they have the potential to detect even the most, faint type of fingerprints. Well, we tried this composition for the first time. We took nanoparticles of alumina. The size was about 14 nanometer. And we coated them with two substances. One was a fluorescent dye, which acts as a colorant. We took crystal violet. And the second was an extract of bean seed powder. Bean seed contains polysaccharides, which have got the potential to, even gum contains polysaccharides. When you try to paste two papers together, the polysaccharides, they bring about the interlocking. The idea of using bean seed powder was that when we spray this powder, it will get stick to the latent fingerprint. And you can see this has broad-based applications. It can detect fingerprints on absorbent items like paper and wood, and even on non-absorbent items like glass and metals. Because it is fluorescent, it can detect weak and faint fingerprints and also fingerprints on multicolored surfaces. To show you an example, these are some representative prints on metal, on paper, and under fluorescent conditions, crystal violet shows yellowish green fluorescence. So this is certainly a better composition as compared to the conventional powder one. But again, there is a limitation that it cannot detect fingerprints on those items which have been deliberately or accidentally despoiled at the crime scene. I once again goes to the component of the sweat. Most of the organic and even inorganic components, they remain unaffected on deposition. Sodium will remain as sodium, potassium as potassium, amino acids as amino acids, proteins and proteins. But then our sweat also contains very small amount of magnesium and calcium. The moment they are deposited, they react with air and they are converted into calcium oxide and magnesium oxide. Both these salts are insoluble. And now they do not react with any fingerprint detecting composition, especially in solution. That is a disadvantage. But the advantage is that if somehow we are able to make them react, then the fingerprints will be last longer. The insoluble inorganic salts in general are very stable as compared to soluble salts. The whitewash in your house is nothing but an insoluble salt of calcium. And if nobody tampers with it, it will remain there for almost 10 years. So if there is a technique, that's what we thought at that stage, if we can fix calcium oxide or magnesium oxide for the purpose of detecting latent fingerprints, then we can detect even, we can detect even if the surface is moist, we can detect fingerprints which are very old because nothing happens to the insoluble salts. We tried out this method with a new type of catalyst called phase transfer catalyst. You are all aware what a catalyst is, anything which increases the speed of a reaction. Phase transfer catalyst is something new to the chemistry. As the name implies, if the two reactants are in different state of matter, then it will bring a liaison between them. In our case, the fingerprint detecting solution, I took rose Bengal. It is in its solution form. It's in the liquid state. And the target compound, calcium oxide, is in the solid state. Normally, they will not react. They will not react. If I take calcium chloride solution and I add rose Bengal, it will give me a purple coloration. So I'm tempted to say that calcium is also present in my sweat. If I spray rose Bengal, it should give a colored derivative, but it doesn't give. Because by the time I spray rose Bengal, calcium has been converted into an insoluble component. It doesn't react. But in presence of phase transfer catalyst, the liaison is brought about. And we can detect fingerprints on such a large number of items, absorbent, non-absorbent, and even semi-absorbents like adhesive tapes or polythene. To show you a few examples, you can see on glossy paper, on glass, as well as thermocol. I have deliberately taken only 3 examples. Glossy paper is semi-absorbent. Glossy paper is absorbent, glass is non-absorbent, and thermocol is semi-absorbent. And it gives clear fingerprints on all. This is what is called broad spectrum applications. Then on adhesive tape, what you see over here, it's a picture of a duct tape. And duct tape is generally used by suicide bombers to tie explosives on their bodies. Prior to this method, there was hardly any simple technique, which could detect fingerprints on duct tape. But then, we changed a little bit, composition change was required, and you can see we obtained a clear fingerprint on duct tape. As I said, calcium oxide is insoluble in water. So if you wash it with water, if you take a moist item, in this case, I took a spoon, dipped it in water for almost 12 hours, and then applied the reagent. And you can see the fingerprint has come out quite clearly. From here, we move to a next technique that is small particle reagent, which is famous for detecting fingerprints on moist items. In the conventional formulation, we use molybdenum 4 oxide, or we also call it molybdenum disulfide. Now, conventional technique has some limitations. Firstly, molybdenum disulfide is almost black in color, gray-black, and it will not give a good contrast on dark-colored surfaces. Secondly, it can detect fingerprints only on moist items. As I go further, I'll tell you there are several other ways to despoil the crime scene. And then, molybdenum being a heavy metal salt, it is quite toxic in nature. We tried to modify this technique. Instead of molybdenum disulfide, we use basic zinc carbonate and a little bit of boron nitride. Both of them together act as adhesive. We use a fluorescent color, basic yellow 40. In the previous technique, there was no coloration. The color was of the adhesive only, that is molybdenum disulfide. Then we added a free-flowing agent, lycopodium. Then to prevent the lumps being formed, we use zinc stearate, and as a binder, we use gum arabic. For wetting it, we use a water surfactant mixture, and the surfactant which we use is a common detergent. We tried out various items, metals, plastics, tiles, glass, and even crockery. And this worked on virtually all the surfaces. Just to show you, we use this in two forms. For dry form on conventional crime scene evidence, and it works on porous items, on non-porous and semi-porous. But for despoiled crime scene, we shake it with little water and detergent, and we can use it to detect fingerprints on those items which have remained underwater for infinite period, which have been buried under soil, and which have been recovered even from arson sites. So, if an item is exposed to water, or it's buried under soil, or even if it is exposed to heat, this formulation actually works quite well. Now, these are some conventional crime scene evidence: paper, glass, and glossy paper. And each latent print was 72 hours old, and you can see it has developed quite clearly. But when we shake it with water, now under fluorescent conditions, this is tin foil, it has become crumpled, but even after 72 hours, it is giving a clear fingerprint with yellowish green fluorescence. We use aluminium foil to study submersion under water. After 2 hours, 48 hours, we could proceed even after 118 hours. And we could get clear fingerprints. Thereafter, the quality, it deteriorated. Then lamination sheet, it was buried under soil for 10 hours, wet soil, taken out, washed under gentle stream of water, and then we applied the reagent under fluorescent conditions, and again, it gives a clear fingerprint. We use items under mock from mock arson sites. We heat the item in an oven. We put it in the oven. Simultaneously, we put a few filter papers and newspapers. Because in actual arson site, a lot of soot is generated. And soot, if it settles on the latent fingerprint, it's very difficult to develop it. So in order to imitate the real arson sites, we artificially generate soot. We take out the item, and first we spray it with water. The reason is that at actual arson sites, the fire brigade personnel, they reach earlier than the forensic scientist. Their duty is not to collect the evidence. Their duty is just to douse the fire. So randomly they spray water. So once again, to imitate those conditions, we first spray them with water, and then we apply the reagent. Now here you can see it gives us fingerprints at 200 degrees, 230 and 260. We are proceeding further also, trying to get fingerprints beyond this temperature. Now what's the mechanism over here? Small particle reagent fixes water immiscible components, mainly fatty acids and lipids. Detergent is an important component of this formulation. We call it a surface active compound. And like any other surface active molecule, it has got an organic end and it has got an inorganic end. The organic end, which is hydrophobic, binds with fatty acid or lipid components of sweat. The inorganic ion, which is hydrophilic, binds with zinc carbonate, basic zinc carbonate. So a hydrophilic interaction is generated, and on that adduct, the dye gets adsorbed. And because the dye is fluorescent in nature, irrespective whether the surface is dark or if it is light in color, we can still get fingerprints under ultraviolet conditions. This was an extension of our earlier work where we had used only basic zinc carbonate without adding boron nitride, and we use crystal violet as the dye, not basic yellow 40. We had a patent of this also. So in order to compare it, what we did was we applied a latent fingerprint, cut it into two parts, developed one with the new composition and one with the old composition. And you can see over here, in the presence of boron nitride, the prints have become more clear, although we added only a trace amount of it. Then crystal violet, as the name implies, it is violet in color. It was very difficult to discern fingerprints on dark colored items. Moreover, it worked only on non-porous surfaces, not on porous or semi-porous surfaces. And even on non-porous surfaces, there was yet another limitation, that if the item has some sprinkling of blood, and a weapon normally has that, then crystal violets started reacting with the hemoglobin content of blood, and the fingerprint got smudged. Moreover, this technique was, this formulation was applicable only on moist items, not on the other ones. But with this novel technique, which is my final, it's cost effective. All the ingredients are non-toxic. It's easy to use. Just 1 or 2 minutes are required to develop the fingerprints. It's fluorescent in nature. And as I will show you in the next slide, it has got multi-purpose applications. As I said, it works on porous, semi-porous, non-porous surfaces. It works on white colored surfaces, colored surfaces, and multicolored also. It can leave fingerprints on dry items, those which are exposed to water, those which are exposed to heat, and those which have been buried under soil. In the dry state, its shelf life is 1 year. In wet state, it is 6 weeks. The developing time is just 2 minutes. And even an amateurish hand can use this. Don't require extensive training for it. Now, this technique, we have given the formulation to few user departments. We are waiting for their report. And on the basis of that report, we are trying to get this commercialized so that we can give this to the police personnel. They don't have to apply their mind to which surface they have to on this, which they have to apply on this. They can use it for n number of surfaces, irrespective of the color, irrespective of the nature, irrespective of the type. So that is my final, formulation. And as I said, we are very interested to get a report from the user department and see what its feasibility is. Thank you so much for patient hearing.